Dubro Suspicion Files.
Every November, if you're lucky, you might catch the Leonids, a meteor shower.
Yeah, it's an annual thing now, pretty predictable. Beautiful, even.
But rewind a couple of centuries, and it wasn't seen as benign at all, was it?
Not in the slightest.
Yeah.
We have to go back to November 1833. That night, it really shook things up, changed how people saw the sky.
The night the stars fell, they called it?
Exactly. Eyewitness accounts, they talk about sheer terror. People genuinely thought it was the end of the world.
Not just a few shooting stars.
Oh, no. We're talking hundreds of thousands an hour. Enough to cast shadows, apparently.
Yeah.
For hours. Just unimaginable.
Looking at those old drawings, reading the descriptions, it hits you, doesn't it? That feeling of awe, maybe even dread, makes you wonder.
What are these things, really?
Yeah, just space rocks burning up.
Or something more. Could they be carrying, I don't know, the secret to where we came from?
That's the big question, isn't it? And it leads us right into our deep dive today.
We've got sources laying out a case for something called cosmic ancestry. Right. The specific idea that life didn't start here. That it arrived, fully formed, maybe riding on comets or meteors.
And the Leonids specifically are presented as a prime delivery mechanism.
That's the core hypothesis we're digging into.
So our mission today, we're going to dissect the three main arguments for this Leonid seeding idea.
Apply some serious scrutiny. Physics, biology, chemistry. The works.
And figure out where the compelling story ends and the hard science begins.
And we need to nail down one key distinction right from the start. This is absolutely crucial for you, the listener.
Okay.
The whole argument kind of pivots on confusing two very different things.
Which are?
The delivery of actual living life, which we'll see is pretty much a fringe theory.
Right.
And the delivery of the ingredients for life, the building blocks.
Okay, amino acids, that sort of thing.
Exactly. And that part is proven, mainstream science. Confirmed by missions.
So the proponents mix those up.
They systematically borrow the credibility of the proven science, the ingredients, to try and prop up the fringe theory about life itself arriving. We have to keep those separate.
Got it. Life versus ingredients. Okay, let's hear the case then. Put on the prosecutor's hat. Lay out the argument as strongly as possible. All right, so the first hurdle for this theory seems obvious. Space is harsh.
Extremely. Vacuum, radiation, wild temperature swings.
How could anything alive possibly survive a trip, maybe millions of years, between planets? Seems like a deal breaker.
That's the immediate objection, yeah. And proponents tackle it head on with their first piece of evidence, the life is tough argument.
This is where Lithopanspermia comes in.
Exactly. Lithopanspermia life traveling in rocks. And the foundation is arguing that maybe life, especially microbial life, isn't as fragile as we assume.
And the star witness here is the tardigrade.
The tardigrade, yeah, the famous water bear. It's become the poster child for extremophiles.
Because of that space station experiment?
Precisely. They literally put tardigrades on the outside of the ISS.
Yeah.
Exposed them directly to space. And some survived, came back, got rehydrated, and were revived. It's pretty staggering proof of hardiness.
That does change the picture. If something that complex can handle raw space.
Right. It suggests survival isn't automatically impossible. And it's not just tardigrades. There's research showing certain bacteria have remarkable resilience to simulated space conditions.
Okay.
We've even found bacteria way up in Earth's atmosphere, like 25 miles high, sort of an aerial plankton.
So point one is, some life forms are tough enough for space exposure.
That's the assertion. Life finds a way, essentially.
But surviving exposure isn't enough. You need a ride, a vehicle.
Correct. And this is where Lithopanspermia gets specific. Life traveling inside rocks, shielded.
Blasted off one planet by an impact, eventually landing on another.
Yes. And the crucial thing here is that this isn't speculation. The transport mechanism itself is proven.
How so?
Meteorites. We find rocks on Earth that we know came from Mars.
We can tell their origin.
Oh yeah, definitively. Isotopic analysis, mineral composition. As of 2012, the sources say 105 meteorites found here were confirmed Martian.
So rocks absolutely do travel between planets. The Cosmic Postal Service is real.
It's a documented fact. The mechanism exists.
But the timing is also important here, isn't it? When this exchange was happening.
Very important. The proponents point to simulations of the early solar system, a chaotic time.
The late heavy bombardment.
That's the period, roughly 4.1 to 3.8 billion years ago. Massive impacts were common. The simulations show a high probability that rocks were blasted off planets, including Earth, and exchanged throughout the inner solar system.
And that time frame
Overlaps perfectly with when scientists think life was first emerging on Earth.
So the argument is the window was open, rocks were flying back and forth just as life was getting started. It could have been seeded from elsewhere, like Mars.
Exactly. Evidence 1 summary. Life is tough enough, and the transport system, rocks, is proven, and was active at the right time.
Okay, that sets a strong foundation. Which brings us to evidence 2, the supposed smoking gun.
Right. If rocks traveled, did one ever arrive carrying proof of life?
This is the famous Martian meteorite ALH 8400.
Allen Hills 8401, found in Antarctica 1984, a really old piece of Mars, billions of years old.
And it caused a huge stir in 1996, NASA press conference, global headlines.
Massive news. A team of scientists published in Science magazine. They claim that inside this meteorite, using powerful microscopes, they found unusual traces.
Not just mineral.
No, structures that look like tiny fossilized life forms, nanofossils they call them, mineralized remnants of ancient Martian microbes.
Wow. So the implication was enormous.
Huge. Proponents basically said, look, evidence 1 shows life can travel in rocks. Evidence 2 is a rock that seems to contain actual fossilized Martian life.
Therefore,
they argue, Lithopanspermia isn't just possible, it's probable. If Mars had life and Mars rocks hit Earth, it's highly likely Earth life was seeded from Mars. The gun, Lithopanspermia, and the bullet, ALH 84001.
a very neat, compelling narrative.
Very.
Which leads to the third piece, the one directly involving the Leonids.
Yes. Evidence 3, the Leonid claim. This shifts the focus from slow, occasional rock delivery to something faster, more frequent.
This is where Hoyle and Wickrmasing come in.
Sir Fred Hoyle and Chandra Wickrmasing, yes. Controversial astronomers, but very influential in promoting panspermia. They argued relying on big meteorites was too inefficient.
They needed a better delivery system.
A constant, massive one, like meteor showers, specifically the dust from Comet Tempel-Tuttle, the source of the Leonids.
So the dust itself is the cargo container?
That's their hypothesis, going back to the 70s, that this comet dust isn't just rock and ice, it's packed with trillions of viruses, bacteria.
Based on what?
Initially, on how interstellar dust absorbs light at spectrum. They argue the patterns didn't match simple dust, but looked more like complex organic matter, maybe even dried bacteria. Comets as lifeboats, basically.
Okay, that's the theory. But they claimed proof, right, from actual observations.
Yes, this is their claimed clincher. They pointed to data from NASA-led airborne missions during the big Leonid storms around the turn of the millennium, late 90s, early 2000s.
Flights above the weather looking directly at the meteors.
Exactly. And Wickrmasing specifically cited this data as, and I'm quoting the sources they use, clear proof that bacterial particles could survive, hence vindicating panspermia.
Clear proof that bacteria survived atmospheric entry in the dust.
That was the explicit claim, that the seeds of life could have survived a fairy passage. They even published a paper titled A Bacterial Fingerprint in a Leonid Meteor Train.
So the argument culminates with, NASA data confirms bacteria can ride the Leonids to Earth.
That's the narrative they present. The theory is vindicated by modern science.
Okay, let's pause there. That is a powerful story. You've got tough life, Martian fossils in a rock, and now NASA apparently confirming the delivery mechanism.
It connects all the dots into a grand cosmic origin story. It makes us aliens in a way. It's very appealing.
And that appeal, that's something we need to be aware of as we shift gears.
Absolutely. We need to talk about confirmation bias.
Our tendency to latch onto evidence that fits a story we want to believe.
Precisely. Because the cosmic seeding story feels so profound, so meaningful, we might be psychologically predisposed to accept the evidence, the nanofossils, the interpretation of the NASA data, without scrutinizing it hard enough.
We've heard the prosecution. Now it's time for the cross-examination, bringing in the context and the hard science. All right, to really pick this apart, we need context. Let's go back to that 1833 storm. It wasn't just panic, right? Science happened too.
Yeah, amidst the chaos, yes. While many people saw omens and the end times, one person saw data.
Professor Denison Olmsted at Yale.
That's right. Immediately after the storm, the sources say he wrote a letter to the local newspaper, the New Haven Daily Herald.
Asking for observations.
Yeah, basically crowdsourcing the data. He asked people across the country to send in all the facts attending this phenomenon, time, location, direction of the streets. It was brilliant, really. One of the first big citizen science projects.
And his newspaper appeal worked. People sent info.
It was reprinted everywhere, and yes, data poured in. Enough for Olmsted to do something crucial.
Which was?
He plotted the paths. He realized if you trace the meteor streaks backward, they all seem to come from a single point in the sky, a radiant point.
In the constellation Leo. Hence, Leonids.
Exactly. And that proved they weren't atmospheric, like weird lightning or something. They were coming from deep space. Cosmic origin confirmed.
That's a huge shift from terrifying anomaly to predictable cosmic event.
It fundamentally changed things. It validated the idea of a cosmic messenger, a proven pathway from space to Earth.
Creating fertile ground for theories about what those messengers might carry.
Precisely. Once you know the highway exists, you start wondering about the cargo. It made grand ideas like panspermia seem, well, less outlandish. It gave the theory a vehicle.
Okay, so the historical stage was set. Now let's look at the main proponents pushing the modern version, especially Hoyle and Wickramasinghe. We need to understand their perspective, maybe their biases.
Right, the cui bono check, who benefits, or rather, what's the underlying pattern here? We talked about patternnicity.
Seeing patterns sometimes where there aren't any.
Our brains are wired for it. And looking at Hoyle and Wickramasinghe's work over like 50 years, a very clear pattern emerges.
Which is?
They didn't just suggest that the Leonids brought life. They consistently applied the same hypothesis extraterrestrial origin to almost every major biological puzzle or outbreak.
Like what?
They claimed the 1918 Spanish flu pandemic was triggered by a pathogen from space.
Seriously?
Yep. Then they argued the SARS outbreak in 2003 was also extraterrestrial.
Okay.
And most recently, they published papers claiming the COVID-19 virus arrived on a specific meteor seen over China in October 2019, dropped down in meteoritic dust.
Wow. So anything new and spreading fast must be from space.
That seems to be the recurring conclusion. It's applying a single preferred answer to diverse events.
What's the scientific critique of that approach?
The big one is that it's essentially unfalsifiable. As the sources note, the standard explanation terrestrial evolution and transmission is always a possibility, and their space origin hypothesis doesn't really make unique, testable predictions that distinguish it.
So if a virus pops up, they can always say space, and it's hard to definitively prove wrong, but it doesn't follow the usual scientific method of prediction and testing.
Exactly. It looks more like fitting events to a pre-existing belief system. This consistent pattern raises a significant red flag about potential intellectual bias when we evaluate their interpretation of, say, the NASA Leonid data.
Yeah.
Are they following the data or making the data fit the theory?
That's a critical question, which makes this next part vital, clarifying the terminology. You mentioned the confusion between different ideas.
Yes, this is absolutely fundamental. We have to separate the three flavors of panspermia because the proponents blur the lines.
Okay, let's define them clearly. Number one.
Directed panspermia. This is the sci-fi version, basically. Proposed by Francis Crick and Leslie Orgel back in '73.
Crick of DNA fame.
The very same. The idea is that some advanced alien civilization intentionally sent life here, maybe in probes, to seed the planet.
Status.
Pure speculation. Zero evidence. Untestable. Fascinating thought experiment, but not science. We mark this one with a big red light. Speculation.
Got it. Number two, this is the main one today, right?
Lithopanspermia, yes. This is the theory that actual life microbes, bacteria, maybe spores, travels naturally between planets, shielded inside rocks or maybe dust.
The one 𝐾𝐄𝐄𝐏 and the Leonid dust claims relate to.
Precisely. This is the core hypothesis we're examining, its status. It's considered a fringe theory.
Fringe? Why?
Because while the rock transport is real, the survival aspect faces huge hurdles. Surviving the initial impact ejection, surviving maybe millions of years of radiation in space, surviving the heat of atmospheric entry. Mainstream science sees little support for life making that journey intact. We give this a yellow light. It's fringe theory.
Okay, so directed is red, litho in yellow. What's the third one?
Pseudo-panspermia. And this one gets a green light. Mainstream science.
Pseudo, meaning false.
Sort of. It means it's not delivering life itself. It's the well-supported hypothesis that only the non-living building blocks of life came from space.
The ingredients we talked about earlier?
Yeah.
Amino acids, sugars, nucleobases.
Exactly. These organic molecules formed in space, on asteroids, in comets, and were delivered to early Earth via meteorites and dust. Life then assembled itself here from those delivered parts.
And the evidence for this one is strong.
Overwhelming. Missions like NASA's OSIRIS-REx sampling Bennu, Japan's Hayabusa 2 sampling Ryugu, they've directly confirmed asteroids are chock full of these complex organic building blocks. It's happening. It's proven.
Okay, so Directed alien seeding, like litho life travels, pseudo ingredients travel.
Perfect. And now you see the potential for distortion.
Proponents of Lithopanspermia, a fringe theory about life traveling.
They consistently take the solid evidence and scientific consensus supporting pseudo-panspermia, the delivery of ingredients.
And they present it as if it supports their claim about actual life surviving the journey.
It's the key maneuver, borrowing the credibility of the green light science to make the yellow light theory seem more plausible. Like saying because flour and eggs arrive at the bakery, fully formed cakes must also be arriving.
Got it. That clarity is crucial. Now we can go back to their 3 pieces of evidence and apply the real science. All right, let's dismantle this. Starting with evidence 1, the life is tough argument, specifically applied to dust particles in the Leonids. Can a microbe survive entry in a tiny dust grain? Time for verification 4. The physics of entry.
This claim collapses very quickly under basic physics, and it starts with correcting a really common misconception.
Which is?
That meteors glow because of friction. Like rubbing your hands together makes them warm.
That's not it.
Nope. It's factually incorrect, especially at these speeds. Friction plays a tiny role compared to the real mechanism.
Which is?
Ram pressure. Think about the speed here. A Leonid particle, maybe the size of a grain of sand, hits the upper atmosphere at 71 kilometers per second.
That's, what, 160,000 miles an hour?
Roughly, yeah. Insanely fast. At that speed, the air molecules literally cannot get out of the way fast enough. They get slammed, compressed violently, and instantly in front of the particle.
Okay. Like hitting water at high speed?
Kind of, but with gas. This rapid compression is an adiabatic process.
You mentioned this earlier, like a bicycle pump getting hot.
Exactly the same principle, just scaled up astronomically. Compressing the air that intensely, that quickly, generates incredible heat, not in the particle itself, but in the air around it.
How hot are we talking?
We're talking over 3,000 degrees Fahrenheit. That's about subsuns in 650 Celsius. Hot enough to melt steel easily.
Wow. So the air itself turns into plasma.
Precisely. The glow you see isn't the rock burning from friction. It's the superheated sheath of atmospheric gas plasma surrounding the particle.
And what does that plasma do to the dust grain?
It vaporizes it.
Yeah.
The process is called ablation. It's not a slow burn. It's incredibly rapid disintegration. This starts happening way up high, around 155 kilometers altitude.
And the particle is completely gone by.
Usually completely destroyed by the time it gets down to about 80 kilometers.
Yeah.
Still way, way above the surface.
So any hypothetical bacteria riding on or in that dust grain?
It's instantly incinerated, vaporized along with the dust. No known biological material, not even a tardigrade encased in hypothetical dust, can survive being turned into constituent atoms in a 3,000-degree plasma.
So the physics makes the dust delivery mechanism impossible.
Absolutely impossible for life. This is different for large meteorites, like ALH 84001. A big rock has enough mass to insulate its interior, while the outside ablates away. But a dust grain has no insulation. It's gone.
Okay, the vehicle fails the physics test. Let's move to verification 5, the ALH 84001 meteorite itself. The smoking gun with the supposed nanofossils.
Right. This is a huge debate for years after the 1996 announcement. Did it really contain fossilized Martian life?
How did scientists finally settle it?
With much better technology that wasn't available back then. A key study came out in 2022, published in Science. They used advanced techniques, nanoscale imaging combined with spectroscopy.
Meaning they could see the structure and analyze its exact chemical makeup at the same time, in the same spot.
Exactly. Mapping chemistry onto structure at a microscopic level. And the results were definitive.
And the verdict on the nanofossils?
They are not fossils. They are not biological in origin at all.
So what are they?
They're the product of purely geological, abiotic, non-living processes that happened on Mars billions of years ago when water interacted with rock.
Water and rock reactions made things that look like fossils.
Yes, specifically 2 processes called serpentinization and carbonization.
Can you break those down simply?
Sure. Serpentinization happens when water, especially water containing dissolved CO2, flows through certain kinds of Martian rock rich in iron and magnesium. This chemical reaction actually produces hydrogen gas and simple organic molecules like methane.
So the geology itself makes organic chemicals.
Yes. And it releases chemical energy, which could potentially feed later life, but it doesn't require life to happen. Then carbonization is where carbonate minerals dissolved in that water precipitate out, forming tiny, complex mineral structures within the rock's cracks.
And these mineral structures just happen to look like tiny segmented worms or bacteria.
They can, yeah. They form intricate shapes that mimic biological forms.
Yeah.
But the 2022 analysis showed unequivocally that their composition and context are purely geochemical, no biology involved.
So, ironically, ALH 80400 is a monumental discovery.
Absolutely. It shows Mars had water, it had rocks, it had chemical energy, and it was creating complex organic molecules abiotically. It had the ingredients and conditions suitable for life.
But it contains evidence against the claim that it holds actual Martian life.
Precisely. It's powerful evidence for pseudo-panspermia, ingredients were present on Mars, and simultaneously strong evidence against lithopanspermia, no actual life found.
It's also worth noting quickly, contamination is an issue with meteorites, isn't it? Things found inside sometimes just grew there after landing.
Oh, absolutely. Several famous cases, like the Argyll meteorite decades ago, had supposed organized elements that later turned out to be terrestrial fungi or pollen grains that got into the rock after it landed on Earth. Contamination is always a concern.
Okay, so the smoking gun fired a blank. Now for verification 6, the final pillar. The NASA vindication from the Leonid flights. The claim of clear proof for surviving bacteria.
This is perhaps the most flagrant misrepresentation of data in the whole argument. It requires us to look at what the NASA experiment actually did and found.
Wickramasinghe cited results from the 2001 Leonid Multi-Instrument Aircraft Campaign, or MMAS mission. What was its real goal?
We looked at the technical paper, the actual NASA SETI document. They were absolutely not looking for bacteria that would be incredibly difficult, borderline impossible, with the instruments they had flying through meteor trails.
So what were they looking for?
They were looking for a very simple molecule called CN, cyanogen. Just two atoms, carbon and nitrogen bonded together. It's a basic building block for more complex organic chemistry.
Why C?
They wanted to test how organic material from the comet dust fared during atmospheric entry. Did the intense heat of ablation break everything down into individual atoms? Or could some molecular fragments, even simple ones like CN, survive?
Okay, testing if any molecular bonds survived the heat. And what did they find regarding CN?
They found surprisingly little CN, much less than expected based on the composition of comets observed directly in space.
Less CN than expected. How did that get twisted into proof that bacteria survived? That seems like the opposite result.
It is the opposite. Here's the crucial part. The scientists running the experiment reasoned that if the simple, presumably fragile CN molecule was mostly absent after entry, it suggested that the original, more complex organic material in the meteoroid wasn't completely disintegrating into tiny fragments or individual atoms.
So the lack of simple fragments implied the survival of larger things.
Exactly. Their conclusion was that the complex carbon-based molecules likely survived the ablation process, or at least the subsequent heating, more intact than previously thought, persisting as larger, more complex, but still non-living organic compounds.
So the NASA paper is actually strong evidence for pseudo-panspermia, that complex ingredients can survive entry.
Precisely. It's one of the best pieces of experimental evidence we have that the building blocks of life, complex organic molecules, can be delivered intact through the atmosphere via meteor ablation.
And Hoyle and Wickramasinghe took that finding survival of complex non-living ingredients and claimed it was proof of survival for complex living bacteria.
It's a complete inversion of the paper's actual findings in conclusion. The very document they cite as proof for lithopanspermia is, in reality, powerful evidence against it and for pseudo-panspermia.
Wow. Okay, let's recap part 3. The physics says dust brings up, life can't survive. The Martian rock fossils are just minerals made by water and rock, and the NASA data touted as proof actually shows the opposite, only non-living ingredients survive.
The entire evidentiary basis for the Leonid seeding hypothesis for lithopanspermia via dust has effectively collapsed under scientific scrutiny.
So if the evidence isn't there, why does this idea persist? Why is it so appealing? We touched on confirmation bias, but let's dig into the psychology a bit more.
Yeah, it's fascinating why these ideas have such staying power. They tap into some really fundamental ways our brains try to make sense of the world.
Like proportionality bias.
Exactly. The bigger the event, the bigger we feel the cause must be. And what's bigger than the origin of all life on Earth?
Pretty much nothing.
Right. So our intuition kind of balks at the idea that something so monumental could arise from, quiet chemistry in a warm little pond or near deep-sea vent using delivered ingredients.
We want something splashy.
We subconsciously crave a cause that feels proportional in scale. A dramatic, fiery, sky-filling event like a meteor storm delivering life from the cosmos that feels appropriately grand. It's like people preferring complex conspiracy theories for major assassinations over the idea of a lone, insignificant gunman. The cause feels like it fits the effect better.
That makes sense. And patternicity plays a role again, too.
Huge role. We talked about Hoyle and Wickramasinghe connecting pandemics to space. The broader Leonid seeding theory does the same thing.
Connecting the 1833 storm, the Marth Rock images, maybe even modern outbreaks.
Into one single overarching narrative. Our brains love connecting dots, finding that pattern, even if the connections are spurious. It imposes order on seemingly random, dramatic events. It's satisfying to see the face in the clouds.
It simplifies complexity. If something weird happens biologically, the answer is ready-made. Space dust did it.
It requires less cognitive effort than grappling with messy terrestrial biology, evolution, and epidemiology.
Which leads to the third psychological angle, the idea that panspermia is an intellectual cop-out.
This is a major critique from many biologists. Panspermia, in the lithopanspermia sense, is appealing because it lets us sidestep the single hardest question in biology.
Abiogenesis, how life actually started from non-living chemicals.
Exactly. That transition is the ultimate mystery. We know the ingredients were likely delivered, pseudo-panspermia, but how did they assemble into the first cell here? Panspermia offers an easy way out.
Just say it happened somewhere else.
Right. As critics point out, it does not answer the question of the origin of life, but merely places it on another celestial body. It pushes the problem off-world to some unknown place and time, avoiding the difficult chemistry problem right here.
So it's comforting because it removes the local mystery.
It substitutes a hard, unsolved scientific puzzle with a simple narrative answer that just relocates the puzzle.
Okay, so we've debunked the Leonid seeding evidence and explored why the idea is psychologically sticky. But science doesn't have all the answers here. What are the legitimate mysteries, the unexplained residue that remain?
Absolutely. It's crucial to acknowledge what we don't know. And there are three big ones relevant to this discussion.
Residue 1 must be abiogenesis itself.
Without a doubt. That remains the central enigma. We have the parts list, thanks to pseudo-panspermia confirming ingredient delivery. We know Earth had the right conditions. But the specific pathway, the sequence of events, the environmental triggers that caused non-living molecules to self-organize, replicate, and become alive, that's still a frontier.
And that gap, that unknown, is where fringe theories can take root, isn't it?
Always. Uncertainty is fertile ground for speculation. Until we have a robust, testable model for abiogenesis, ideas like panspermia will keep finding psychological purchase.
Okay, what's residue 2? Something about the Leonid source.
Yeah, comet Tempel-Tuttle itself. Even though we know life isn't surviving the trip in its dust, the comet is still interesting organically.
Why? What don't we know about it?
Well, spectral observations show it's a bit unusual. Compared to many other comets, it seems to be lacking silicate emission.
Meaning less rock dust.
Potentially. It might be richer in ices and volatile organic compounds than typical comets. Its precise inventory of complex organic molecules, the ingredients it carries, isn't fully mapped out.
So while it's not delivering life, it might be delivering a unique or particularly rich set of building blocks that we still need to understand better.
Exactly. Studying its composition could still teach us a lot about the kinds of ingredients available to early Earth, further refining our understanding of pseudo-panspermia. There are still secrets in that dust, just not living ones.
And the final mystery, residue 3.
The big one, extraterrestrial life itself. We've concluded life probably didn't travel here via lithopanspermia, but that says nothing about whether life started and exists elsewhere.
The search for life out there is still very much mainstream science.
Absolutely critical science, finding those abiotic organic molecules on Mars, confirming liquid water oceans under the ice of Europa and Enceladus. These discoveries make the search for life beyond Earth more compelling than ever.
So even if panspermia, litho, is wrong about delivery, the possibility of life elsewhere is a separate, valid scientific pursuit.
Completely separate. The search for cosmic life continues. Regardless of the verdict on rocks or dust carrying it between stars or planets, that search stands on its own scientific merit.
A crucial distinction to maintain. Hashtag tag outro. Okay, let's wrap this deep dive up. Time for the verdict.
The conclusion seems pretty clear. The evidence put forward for the Leonid seeding hypothesis for the lithopanspermia, life arriving via dust, it just doesn't hold up.
It relies on misinterpreting the Martian meteorite data.
Which actually showed abiotic geochemical processes.
And fundamentally inverting the results of the NASA Leonid flights.
Which strongly supported the survival of complex non-living ingredients, bolstering pseudo-panspermia, not lithopanspermia.
And the physics of atmospheric entry makes the survival of any life in tiny dust particles basically impossible due to ram pressure heating.
Right. The proponents took the solid green light evidence for pseudo-panspermia, ingredients arrive, and tried to paint it as support for the highly speculative yellow light theory of lithopanspermia, life arrives.
Driven, it seems, by powerful psychological biases, wanting a grand cause, seeing patterns, and avoiding the tough question of how life started here.
Proportionality bias, patternicity, the intellectual cop-out,
Yeah.
they all make the story appealing, even when the facts contradict it. The real challenge is facing the mystery of abiogenesis head-on here on Earth.
So back to that image of the Leonid meteor shower. When we look up, are we watching our own origins streaking across the sky?
Well, in the literal sense argued by Hoyle and Wickram as in watching bacteria rain down, the science says definitively no, that's not happening.
But there's another way to look at it.
I think so. In a deeper, more profound sense, maybe the answer is yes.
How so?
We aren't watching life being delivered, but we are watching the confirmed ongoing delivery of the very stuff we're made of.
The building blocks.
The amino acids, the nucleobases, the complex organic molecules forged in interstellar space and inside asteroids and comets like Temple Tuttle. Those ingredients are part of our origin story.
So not alien life arriving, but the raw materials from the cosmos delivered annually.
Exactly. We're watching the delivery of stardust, the fundamental chemical components that enabled life to begin here. We are, in that sense, children of the cosmos. Those streaks are cosmic messengers, just carrying ingredients, not the finished product.
And deciding how profound that connection really is.
That judgment, whether being made of stardust is as significant as being delivered by stardust. Well, that's something for you, the listener, to ponder. Maybe dig into abiogenesis research. Sometimes the scientifically grounded answer is the most amazing one of all.